flowcharts and triangle congruence today. Flowcharts can be used to represent everyday situations. For example, yesterday Joe found out that 3 people in his family, including Joe, wanted to see a movie, so he went to the theater and bought tickets. Unfortunately, while I was gone, 3 more family members decided to go. When everyone arrived at the theater, Joe did not have enough tickets. Joe sat down later that night and tried to create a flowchart to describe what had happened. These are 3 possibilities that he came up with. So, which of these flowcharts best captures the situation, and what's wrong with the other 2 flowcharts? So, I would say kind of take a look at these 3 and see which one makes the most sense to you. So, if we look at the first one, it basically says Joe bought tickets for 3 family members, 3 members of his family. Actually, you know what? I'm sorry. Let's go to 2 first and talk about that. So, Joe bought tickets for 3 family members, which made 6 family members of Joe's family decide to go to the movie, which made Joe not have enough tickets. So he bought 3 tickets, which made 6 want to go. So he didn't have enough. So this one doesn't make sense because it's circular, right? We're basically saying this caused this, which 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 there's really no beginning and no end to this. So I would say 2 is a bad idea. So I want to eliminate 2 because historically most kids don't choose 2 as the option. They choose 1 or 3. And it really has to do with cause and effect. 1 is saying Joe bought tickets for 3 family members, which made 6 people want to go, which meant he didn't have enough tickets. 3 says he bought 3 tickets and 6 family members decided to go, which meant he didn't have enough tickets. So 1 is basically saying 6 people wanted to go because he only had 3 tickets. I'll give you a perfect example. I have 3 kids. Years ago, we were going to see a movie. I said, who wants to go? 2 of the kids said yes. The 3rd kid said no. I said, fine, we'll leave you at home. We're going to go with just the 2 kids. That made the 3rd kid want to go. Literally, he didn't want to see the movie, but he didn't want to leave. He didn't want to be left out. So that was an example like 1 where saying, hey, I'll take 2 kids. So the 3rd one said, well, geez, don't leave me alone. So then we all went. That's not what happened here. What happened here is he bought 3 tickets and independent of that, 6 people decided to go. So I hope you can see the difference between 1 and 3 and why 3 is a better choice. Because 1 is saying buying 3 tickets caused 6 people to want to go. 3 is saying he bought 3 tickets and, oh, by the way, also 6 people wanted to go, which is a better explanation of what happened in the story. So 3 is going to be the better choice there. All right, so 743. For each pair of triangles below, determine if the 2 triangles are congruent. If the triangles are congruent, provide justification by organizing your work in a flowchart. If the triangles are not congruent, or if there's not enough information to determine congruence, right cannot be determined. So first one, we only have angles. We only have angles here. I'm going to say it's not congruent. And we are definitely missing like at least a side. Because remember, our 2 choices for triangle congruence at this point are angle, side, angle, and angle, angle, side. Either way, we're going to need at least one side. We don't have a side here. How about this one? This one is interesting. Here we have angles that are the same and angles that are the same. And DB, if you look at the top triangle, DB is a side. And if you look at the bottom triangle, DB is a side. So this is actually known as the reflexive property. And it's something that you really need to make sure that you understand. The reflexive property says that something is equal to itself. DB is equal to DB. It just so happens DB is the side in the top triangle and DB is the side in the bottom triangle. So yeah, we can say that this is true because of angle, side, angle congruence. So let's go ahead and make a flow chart for this one. What we would say is, I would say I know the angle, and we're going to talk about angle A. I know what angle A is. There's only one angle there. But when I say angle D, am I talking about the top, the bottom, or the whole thing? We don't really know. There's 3 possible angles at angle D, whereas angle A only has 1 possible angle. When we're in that situation, when we name an angle, this is known, the corner of the angle is known as the vertex. And it literally is like a child would do with their fingers. So let's say that this was PQR. If a child wanted to name this angle, they would take their finger and they would say it's angle PQR, or they would say it's angle RQP. Either way, you'll notice that the vertex goes in the middle. Now, what often happens is kids try and name this angle, and they'll say, oh, it's angle Q, but then what are you going to say, QPR? Well, that's not the angle we're talking about. Or you might say QRP, but again, that's not the angle we're talking about. We're talking about PQR or RQP. So, two things we just discussed that are really important. One is when you can use one letter to name an angle, when there's only one angle there, versus when you have to use three letters, when there's multiple angles and you're choosing between. And then if you have to use three letters, the vertex has to go in the middle. It doesn't matter if you go P or R first, but it does matter that Q is in the middle. So when you look at something like this, you know that you're actually talking about angle Q because it's in the middle, and I hope that makes sense. So that was kind of an aside to go over here and talk about how I'm going to name these angles. So if I want to say this angle right here, angle ADB, I'm going to say angle ADB is congruent to angle CDB. Now, you could have just as easily said angle BDA or angle BDC. It doesn't matter, but what is important is that the D is in the middle on both of those. And how do I know that this is true? Well, this is given by ticks, right? It was given by this corner. I know this is a 90-degree angle. The next thing I'm going to say is I'm going to say DB, side DB is congruent to side DB. Now, a lot of kids will say, well, I feel like it should be DB is congruent to side BD. I literally don't care. It doesn't matter which one you do there. Again, DB and BD are the same side length. The question is, how did we know? If you'll recall, this tick wasn't there originally. We put that tick in because we said, oh, hey, the side length is the side in both, same as in both triangles. That's known as the reflexive property. And I will say, if you have the note sheet that goes with this chapter, you should fill that out. We really need to know what the reflexive property is. The last one is angle B. Again, angle B is undetermined. Do I mean the top of angle B, the bottom of angle B, the whole thing? I need to use three letters, which means the vertex needs to go in the middle. So I'll say angle A, B, D, all right? And I say ABD, I'm talking about this sliver up at the top. And just to change it up, instead of saying CBD, I'll say DBC. It's congruent to angle DBC. And again, when we look at that, I hope you notice I'm talking about DBC, the bottom part. So I'm saying the top part of B is congruent to the bottom part of B. B is in the middle, the vertex both times, and again, that is given by ticks. So now I have proven angle, side, angle, right? So I can say, all right, well, I know triangle ADB is congruent to triangle. Well, A is the unknown angle, so C is the unknown angle. D is the 90-degree angle, so I got to go with D because that's the 90-degree angle. And B has one tick, and B has one tick. And again, how do I know? It's either angle, side, angle, or angle, angle, side. Well, this side connects the angles, so the S connects the A's. So I will say that is true because of angle, side, angle congruence. I hope that makes sense to everybody. It's definitely a little bit tricky, but it's really attainable if you kind of pay attention to what's going on here. Now, obviously, we're a little bit close on this one, but let's take a look. Hey, look, we have another reflexive side. These angles are the same. Well, anytime you see a parallel line, everybody always thinks if you see parallel lines, you should be thinking of sides. You should be thinking of corresponding angles, right? They're both in the top right, they correspond. You should be thinking of alternate interior angles. Alternate exterior angles. I'll put an E for alternate exterior angles, or they're outside of the parallel lines and they're on opposite sides. Or maybe you want to talk about alternate interior angles, where they're inside the parallel lines and opposite. All these relationships are ones that we need to know. And again, I would say go back to the note sheet for the chapter and make sure you fill these in. This is a review of like 7th and 8th grade, right? Like we should know these angle relationships. From teaching over the years, I know a lot of us don't. So anyway, the bottom line, a couple of points. We're going to spend some time in chapter 7 going over those and seeing some examples. But long story short, whenever we see parallel lines, we want to be thinking about angles. So hey, these are parallel lines. By the way, this caret symbol means parallel. This tick means equal length. So what happen a lot of times is kids will see this here and say, oh, look, I can say GH is the same as FE. That's not what it's saying at all. What it's saying is that they are parallel. So again, if I extend these parallel lines in this transversal, I hope you can see that we have alternate interior angles right here. So I'm going to go back and I'm going to say that these angles are alternate interior angles right over here. This angle is an alternate interior angle. to this angle. Again, if you extend those parallel lines and the transversal, you can see that. So when I look here, I have this reflexive side, and it looks like I have angle, side, angle, angle, side, angle. Again, when we decide if it's angle, side, angle, or angle, angle, side, we don't get to go from one triangle to the other. You wouldn't get to go say, hey, look, this angle from this triangle, this angle from this triangle, and this side, so it's angle, angle, side. No. We look at the top triangle, and we see that side connects the angles. We look at the bottom one, and we see that side connects the angles. The other thing is we need corresponding, right? Corresponding parts. This side is opposite the unknown angle. This side is opposite the unknown angle. So we are pretty convinced that these triangles are congruent. So again, I will say, hey, look, this right here, angle F, it could be anything, but I want GFH, angle GFH is going to be congruent to angle, it has one tick, so I'm going to use this one, FHE. And how did I know that? I knew that because it was given by ticks. The next one, I knew FH was congruent to FH. So side FH was congruent to side FH, or HF, doesn't matter. How did I know that? Again, I knew that because they are reflexive sides, right? And then the last thing is, I knew this angle, GHF, angle GHF, is going to be congruent to angle, again, this has two bands, so I'll go with this one, EFH. And I knew that because, again, I figured that out because if lines are parallel, then alternate interior angles are congruent. Technically speaking, we should say if lines are parallel, that's the parallel symbol, then alternate interior angles are congruent. That's a lot to write, so typically people will just say alternate interior angles, and I'll accept that. That's fine. All right, so as we go along here, we have proven triangle congruent. So I'm going to say triangle GFH is congruent to triangle. Again, G is unmarked, E is unmarked. F has one tick, H has one tick. And in this one, I don't know if I said F and H. Okay. Anyways, H here has two bands, and F here has two bands. So again, you'll notice the F and the F's don't go together, and the H's don't go together. It really isn't always that obvious. You need to look at the bands to determine that. And again, we said that was because of angle side angle congruent. So if we look at this, we said A wasn't congruent, but we said that B and C were, and then we made flowcharts that go with both of them. I do want to point out, if you look at B, these are clearly not congruent triangles by the way they look, but that doesn't matter. We have to go by the tick marks. These two triangles are clearly not congruent triangles, but again, that doesn't matter when we're doing this. We're just going by what is shown to us and what has to be true using our logic. So we can definitely prove given, we can prove reflexive, and we can prove that if parallel signs are, if lines are parallel, then alternate interior angles are congruent. And again, that looks like this. These are alternate interior angles. They alternate across the transversal, and they're inside or interior of the parallel lines. All right, so we will go ahead and finish this up. Lesson 714 by looking at, I guess, D and E, and then we'll go to problems 744 and 745. So if I look at this one, a couple things. A lot of kids on this one will say, yeah, these things have to be congruent for a lot of reasons. One, they'll say, this side is 4. And I'll say, well, how do you know this side is 4? There's nothing telling you this side length, so we don't get to say this side length is 4. The other thing is they'll say, oh, look, these are alternate interior angles because these lines are parallel. There's nothing saying these lines are parallel. I mean, they sure look parallel, but again, we can't go by what they look like. So when we look at this, we have a side and an angle. That's all we have. That's not enough. We can't say that these are congruent. They might be congruent, but we don't have enough evidence or proof yet. We would need more stuff filled in to be able to say they're congruent. So again, we don't have enough to say that here. And then on this one, I think this is kind of interesting because I want to change your perspective on E a little bit. I want to break these triangles up. And I want to show you what I mean by that because they're a little bit hard to look at when they're together. But I have angle DAB here, and I have angle ABC here. So you can see I've broken these ones up. So angle D is the same as angle C. I know that's given. Angle A here, I'll just put 1, is the same as angle B here. Again, that's given. But here's the last thing that we know, even though it's not said. Isn't AB the same in both of these? Isn't this side reflexive to itself? So now if we look at this, even though it looks like a big mess, by pulling them apart, which is a strategy I would tell you to do, pull them apart and look at them, but don't forget that reflexive side. You can see that we do have angle side congruence. Across from 2 ticks is the side, across from 2 ticks is the side. So I can say, hey, I know angle D, and again, I'm allowed to call this angle D because there's only one angle here. If you want to call it angle ADB or BDA, that's fine. You'll never be wrong if you use 3 letters. But you can be wrong if you only use 1 letter. My advice is know what you're talking about. I know that I can say angle D is congruent to angle C. And I know I can say that's because of given. I know that I can say, again, this one right here, if I'm looking at this triangle, I can't say B. There's a lot of angles here. I have to say angle DBA. So angle DBA is congruent to angle CAB. And again, you could kind of look over here and say, well, look over here, it's just A and a B, but that's not what it looks like when it was given to us. And we know that is also given. And then finally, we know that side AB is reflexive to side AB. And again, if you want to say AB and BA or whatever, it doesn't matter because they're the same side length. But we have gone about and proven, and I'll give myself a little bit of room here to finish this thing up. We have proven this is true because of angle side. So I'm just going to say, all right, well, now I know this has given me enough to prove that triangle ADB, again, I could have chosen anything here, but I chose ADB. ADB, that's congruent to B. All right, this big A is what I was talking about. So the big B is what I'm talking about. D here goes with C. And here, this B was like the little b right here, so it's the little a right here. So you can see, again, A's don't match up and B's don't match up in this particular problem. Sometimes they do, sometimes they don't. And again, we said that we know that's true because of angle side congruence. So a lot going on with that particular problem. I hope that made sense to you. Because it is a little bit tricky, and we went through quite a few things right there that might have been new for you. And finally, we'll end it up at 744 and 745. 744 says, what single rigid transformation would show you that CAB is congruent to DBA? So what can I do there? I can reflect it, right? If I reflect this triangle, that will match up there. These little slivers will match up, and then the fat corners will match up. The obtuse angles will. All right, and then finally, 745, consider MNPQ, this square, with diagonals intersecting at point R, shown at right. How many triangles are in this diagram? Hint, there's more than 4. Well, there's 1, 2, 3, 4, 5, 6, 7, 8. There's at least 8. I don't know if there's more than that. Anyway, so how many lines of symmetry does MNPQ have? Well, we have one here, we have one here, we have one here, we have one here. So it looks like we have 4 lines of symmetry here. And it says, write as many triangle congruent statements that involve the triangles in this diagram. Be prepared to justify each of these. I really don't want to do that. Essentially what we're going to say is this little triangle is the same as this little triangle is the same as this little triangle is the same as this little triangle. And then we can say that this triangle is the same as this triangle is the same as this triangle is the same as this triangle. So there's a lot going on here. I think what I do want to do is jump over to the answer key and show you guys that, because I think that'll be a nice shortcut for me. So we're looking at 714, 745. So maybe I made some mistakes. I don't know. Maybe there's more than 8 triangles or whatever. Now there was 8 triangles. Then the second question again was how many lines of symmetry? That's right, and we said that there was 4 lines of symmetry, and then we said we can say that the small triangles are congruent to each other. I forgot I can't write on that. And then we said that the big triangles are congruent to each other. So that's your solutions there. Again, I just didn't want to go through the trouble of that.